At the course readings for the week 1 of Econ 1005. We will look at the definition of terms like statistics, inferential and descriptive statistics, population and sample, variables, data, parameters and statistic, qualitative and quantitative data, discrete and continuous data. We'll also look on scales or levels of measurement, nominal, ordinal, interval, and ratio. Now, statistics is defined as scientific methods for collecting, organizing, summarizing, presenting, and analyzing data, as well as drawing conclusions and making reasonable decisions based on this analysis. And that is what this course is all about. We're going to be looking at how to collect data, organize data, summarize data, present data, and analyze data so as to draw conclusions and make reasonable decisions about the data that we have collected. Now, there are two main branches of statistics. There's descriptive statistics and inferential statistics. Descriptive deals with that branch of statistics where you are just collecting, organizing, and presenting the data using tables, charts, graphs, diagrams, etc. And if you're using numerical measures, it would be like mean, mode, median, or average, and percentage. So you're just really describing the data that you have collected, summarizing that data that you have collected using simply charts and simple numerical methods or measures. Now, inferential statistics, here you are going to make generalizations about the population based on the data that you have collected from the sample. So here you have collected data from a sample, and you're going to use that data to make generalizations or inferences about the population. Okay, we're going to look on an example here. Now, in a January issue of a city newspaper, there are 5 supermarket advertisements that features onions and potatoes. The price is per pound. So we have 5 stores, store 1, 2, 3, 4, 5. In store 1, the onions cost 69 cents, while the potatoes cost 39 cents, etc. Okay, so that was the advertisement in the newspaper. Now, we have some questions. We have 5 statements here, and we need to indicate if the following statement, for each of the following statements, whether it's descriptive or inferential. Now remember, descriptive describes basically the information that is there, while inferential statistics use the sample data and make estimations or generalizations or inferences about the population. Here we have a sample of 5 stores. Okay, so bear that in mind. Let's look on the first statement. 2 of the stores had the same prices for onions and potatoes. Okay, you decide whether you think that's descriptive or inferential. Make a note of that. Number 2, of the 5 stores, the one with the least expensive onions also had the least expensive potatoes. Is that descriptive or is it inferential? In this city, onions are more expensive than potatoes. Descriptive or inferential? Okay, please make a note. Number 4, the difference between the highest and the lowest costs of onions for the 5 stores surveyed was 26 cents. And the last one, store number 5 had the least expensive produce. Alright, I'm going to give you 15 seconds to look back again at the questions and make a note of your responses, and let's see if you are correct on the next slide. Okay. First one, your answer should be descriptive. You're just describing the information that's there. Two of the stores had the same prices for onions and potatoes, right? Store number 1 and store number 2 had the same prices for onions and potatoes. So that's descriptive. You haven't made any generalizations about the population there. Number 2, of the 5 stores, the one with the least expensive onions also had the least expensive potatoes. Okay, and that's store number 5. And here we're just talking about of the 5 stores. So we haven't made any generalizations. So this is descriptive. Number 3, in this city. Now realize you have gone outside of the 5 stores and you're now talking about all the stores in the city. You said in this city, onions are more expensive than potatoes. So you have used information that you gathered from the 5 stores and you have made a generalization about all the stores in the city. You said in this city, all onions are more expensive than potatoes. So this is inferential statistics. Number 4, the difference between the highest and the lowest cost of onions for the 5 stores surveyed was 26 cents. Again, you're just talking about of the 5 stores surveyed. You haven't gone outside of that. You haven't made any generalizations about the population of all the stores in the city. So this one is descriptive. Number 5, store 5 had the least expensive produce. Now realize we only had data on onions and potatoes. But statement number 5 is talking about produce. So that is including everything else, yam and dasheen and pumpkin, etc. Right? So we have gone outside of just the onions and potatoes and made a generalization about all the produce. So that one is inferential. All right, we're going to move on. Population. In statistics, population is the entire collection of people, animals, plants, or things from which we may collect data. In other words, it's all the items, objects of interest to the researcher. So whatever the researcher is interested in collecting data from, that is defined as your population. So an example of population is all the preschoolers in the Caribbean. Okay? Now here's a question for you to try. You are asked to identify the population for this study. The research question is, do newborn babies who are cuddled a great deal during the time they spend in the hospital show greater weight gains than those whose feeding needs are met but otherwise are left in their cribs? You need to identify the population for this study. I'll give you 10 seconds to read the question again and identify the population in this study. All right. A, all newborn babies in the hospital. Right? The question said who are cuddled a great deal during the time they spend in the hospital. Okay, so you're gathering data from those babies, all the newborn babies in hospitals. Now a sample is a subset or a group of or a group from the population, part of the population. That's your sample. So earlier when we said that our population was all preschoolers in the Caribbean, a sample would be all preschoolers in St. Lucia. All right, now here's a question. A survey of 2,625 elementary school children found that 28% of the children could be classified as obese. You need to identify the population and the sample. A survey of 2,625 elementary school children found that 28% of the children would be classified as obese. What's the population in this case? And what would be the sample in this case? Okay, the population is all elementary school children. Okay, you are interested in collecting data from all elementary school children. However, you have gathered data from 2,625 school children, so that's your sample. All right. The 28% is not your population nor your sample. It's just that from your sample, you have found that 28% of the children were classified as obese. Now another term, a variable. A variable is any characteristic of a population or sample that is of interest to the researcher. So if the researcher is interested in collecting data on person's weight, age, IQ tests, gender, etc., that's your variable. Okay, so that variable changes from one person to another, or from one object to another, whatever the researcher is investigating. Now, a parameter is a numerical value that is calculated from a population. A parameter is usually unknown, and therefore it has to be estimated. It's usually unknown because most times our population is so large we cannot get to all the items in a population. Hence, you can't calculate that parameter value. Okay, so in most times it's estimated. So if you consider our population of interest to be all the students enrolled in Econ 1005, the average age of all the students in this course will be a parameter, since it is calculated by using the ages of all members of the population. And we denote this average age mean as mu because it's a population mean. So this symbol mu symbolizes or denotes population mean. Now, a statistic is a numerical value that is calculated from a sample. For example, the average age calculated from a randomly selected sample of Econ 1005 students is a statistic. Let me say that again. You're calculating the average age from a sample. Okay? So that average age, that value would be a statistic. Alright, now it's the average or mean again that we calculated, but notice the symbol here is a little different than the previous one. This is X bar to indicate sample mean. Okay, so while mu was used to indicate population mean, we have X bar to indicate sample mean. Okay, now the statistic may be used to estimate the parameter. Okay, here's a question. A recent survey by the alumni of a major university indicated that the average salary of 9,000 of its 300,000 graduates was US $125,000. Does this value describe a population parameter or a sample statistic? Okay, you should have your answer by now. Okay, this is a statistic. You're looking on 9,000 of the 300,000 graduates. So that's a sample. Okay, so that's a sample. So the value calculated will therefore be a statistic. Here's another question. A research study attempts to survey the population of all students at a university. 2 surveys were conducted by 2 different researchers. Which statement best describe the results of the 2 studies? Okay, so it's one university and 2 studies are being conducted at that university by 2 different researchers. So you have 4 options. Which statement best describe the results of the 2 studies? Your answer should be that the parameters remain constant, but the statistics vary. And that's because they're looking at the same university, the same population of students. So their parameters, that numerical value calculated by using all the items in the population, that should be the same for both researchers. However, the researchers will have different sample, so therefore their statistic values would be different. All right, now earlier we looked on variables as any characteristic of interest to the researcher. Now data refers to the actual measurements or values or observations of those variables. Data can be broken down into two groups, qualitative and quantitative data. Now qualitative data is data that is expressed in words, while quantitative data is data that is expressed numerically. So your age, that would give you a numerical value, so that's quantitative data. While your month of birth, September, October, January, those will be qualitative data because that's in terms of words. Now, data is classified as discrete if the values are integers or they are discrete and separate. Okay, discrete data have exact values. For example, the number of persons in a household, that's an exact value. The number of patients in a doctor's surgery, that's an exact value. Gender, male or female, okay, distinct and separate. Your blood group, you're either type O, type A, type B, type AB, etc. So distinct and separate. So those are discrete. All right. Now, qualitative data like gender and blood group is always classified as discrete. Okay. Now, quantitative data can be broken down into either discrete or continuous. Okay, so earlier where we have the number of persons in a household, that's a quantitative data, right? So quantitative data can either be discrete or continuous. So continuous, exact values, distinct and separate. Another way of looking on discrete data when we are talking about quantitative data, if it is countable, if it's something that you're counting, then it is that's an easy way to look on it as being discrete. The number of persons in a household, that's something you would count. The number of patients in a doctor's surgery, that's something you will count. All right, so that's discrete. Now the other type is continuous. Continuous variables lie in a range. Okay, if your height is 6 feet, is it exactly 6 feet, or is it 5.98? which rounds off to be 6 feet, or is it 6.01, which rounds off to be 6 feet? If you say you did an exam in 20 minutes, is it exactly 20 minutes? Okay, or 19 minutes and 45 seconds. Okay, right, so values that lie in a range, that is continuous, or another way of looking at it, things that you measure. Time is something that you measure. Height is something that you measure. Weight is something that you measure. Temperature is something that you measure. The amount of sugar in a drink, that's something that you measure. Okay, so here's a question now. For each of the following variables, state whether it is qualitative, quantitative and discrete, or quantitative and continuous. The number of rainy days in a month. Okay, that would be quantitative because it's the number of. So that's a number, so it will be quantitative. Now the number of rainy days in a month, is that discrete or is that continuous? That would be discrete. Okay, that would be something you count. The amount of rainfall in a month. The amount of rainfall, so that's quantitative, because you're going to say 1 inch or, that's how you'll measure the amount. So it's quantitative, and I indicated the keyword there, measure, so it will be continuous. And the weather forecast for a particular day, windy, hot, snowy, bleaky, that would be qualitative. All right. Okay, discrete and continuous. A city council commissioned a research project to investigate the factors that seem to contribute to traffic congestion in the city. Data on the following variables were collected. Okay, so you have 5 variables there. You need to take 15 seconds and look on each variable and classify them as whether it's discrete or continuous. Okay, if I'm going too fast, you can pause the recording and click continue whenever you're ready. Okay, your speed of vehicles, that should be continuous. That's something you measure. Number of vehicles per 100-meter length of roadway, that's something you would count. That's discrete. The number of vehicles passing a particular point per minute, that's discrete. The time taken would be continuous. And noise level measured would also be continuous. Now, scales of measurement. This is a required reading for the first week of the course. Scales of measurement. Now, all data may be classified according to 4 levels or 4 scales of measurement. These are nominal, ordinal, interval, or ratio. Now, the nominal level is the simplest or the lowest level of measurement. And nominal really comes from the word name, right? So the data are classified into groups according to some name, according to some characteristic or some attribute. For example, your blood type, A, B, AB, or O, right? So you're classified into these different groups, and these groups are distinct and separate from each other. You can't be blood type A and also blood type O, all right? So you're in one group. Okay, you can't be born October and also born December, right? So months of the year will also be classified as a nominal level of measurement. Now, these values, this data here cannot be mathematically manipulated. Okay, what you have here, A, B, A, B, O, what can you do with that in a mathematical sense? Only thing you can really do is to tabulate and say, okay, we have 5 persons with blood type A, 7 persons with blood type B, 10 with AB, etc. Or 20% of the persons with blood type B, right? So that's some simple thing, you can do with those, with data in that sense. Now, ordinal data, this is a step up from the nominal scale. And as the name suggests, ordinal indicates some order. So the data, in addition to being assigned into groups, are also assigned an order or a sequence or a rank in terms of a graded order, right? For example, above average, average, below average, right? So you're either an above average student, an average student, or a below average student. You can't be in more than one categories. All right, and here we can rank these. The above average is more than the average. Okay, however, we cannot measure how much more. Okay, what's the difference between the above average student and the average student? We can't really quantify that. All right, so data may be ranked numerically. We can use numbers here. We can say above average is 3, average is 2, below average is 1. We can assign numbers, right? Similarly with nominal, we can assign numbers. If it's months of the year, January would be 1, February would be 2, but those numbers don't really mean anything for nominal. Okay, and for ordinal, these numbers would be arranged in order of some ranking. Now, interval data, this is a step up from the ordinal. As you move up the levels, the sophistication increases. So interval is a step up above the ordinal. The groups are not only ranked or ordered, but are ordered with equal measurements between them. All right. So if it is 80 degrees in St. Kitts and 40 degrees in New York, okay, this does not mean that it is twice as hot in St. Kitts. All right, there is a 40-degree difference. Right, there's a 40-degree difference, but it doesn't mean that St. Kitts is twice as hot as New York. Right, so temperature is an interval data. You can that difference. Right, the groups aren't the values aren't ranked, but they have equal measurements between them. Now the ratio is a step up to that. Or another point I should make with the interval is that interval, there's no zero. Okay, there's no real or rational zero. Zero on the thermometer, where we're talking about temperature. Yes, you may say that zero is on the thermometer, but zero does not signify a total absence of heat. So there's no absolute zero when it comes on to the interval measurement. With the ratio, there is zero. Okay, the 0 point indicates a complete absence of the characteristic being measured. Okay, so height 0. That means there is a absence of height, right? And weight. Okay, and a thing with the ratio, let's look on height. Let's say somebody is 6 feet tall and there's another person who is 3 feet tall. The one who is 6 feet tall is twice as tall as the one who is 3 feet. Okay, so you can do that with the ratio levels of measurement. All right, so the 4 levels represent increasing sophistication. The higher levels yield more information, etc. All right, now let's look on an example. We need to identify the scale of measurement or the level of measurement. A researcher is measuring class as an income variable. The variable is the amount of income a person makes in a given year. Okay, the amount of income a person makes in a given year. Is that nominal, ordinal, interval, or ratio? Your answer should be ratio. Okay, if somebody makes 100,000 in a given year and another person makes 50,000, then the one who makes 100,000 makes twice as much as the one who made 50. So that's ordinal. Now the same researcher decides to collapse the income variable into the following categories. So between 0 and 10,000, they classify that as 0. Between 10,000 and 1 and 20,000, they classify that as 1, etc. All right, we need to identify this as nominal, ordinal, interval, or ratio. I'm sure you can see the order there. Okay, the ranking. So it's ordinal. Okay, so that brings us to the end of the presentation for week 1. I trust that this presentation was helpful.